So I would like to welcome Branko Rico, the Human Footprint and Land Use Mapping Coordinator at the ABMI, to tell us all about mapping human footprint in Alberta.
Hey everyone, thank you Sydney for introduction, and I'm happy to see some familiar names in today's turnout. And Sydney, before we go, are you able to see my screen? I'm seeing some difficulties in here on my side, but hopefully everything's okay.
Looks great.
Looks okay. All right. Okay. My name is Branko, and we have prepared this presentation for you to provide overview of human footprint inventory program within ABMI. I've been with ABMI since 2014, so I'm pushing 8 years. I lead human footprint inventory mapping, and I'm involved in some data acquisition outside of the human footprint inventory mapping program. And maybe I can just switch off camera in here. And today, what I would like to talk about is obviously HFI mapping, but also, more about data set structure, sublayers, integration process of sublayers to create integrated layer of human footprint for entire province. At the end, I'm going to dedicate a couple of slides and piece of this presentation, this webinar, to accuracy, because rightfully so, this is probably one of the most frequent questions that we get every time we present our data set. Q&A at the end, hopefully, Sid, please correct me if I'm wrong, 15-20 minutes for questions period. And in the middle, I'm going to be highlighting very important component of ABMI and Government of Alberta initiative, HFMP, which stands for Alberta Human Footprint Mapping Program. Sid, you have actually stirred my thunder in here, because I would like to start with quote, "You manage what you measure." And essentially on the question of why do we map human footprint, or why a human footprint mapping matters, is that each and every land use manager needs to make decisions based on existing data set, and better data set, higher quality data set, better decision is possible, right? So we want to allow all these managers, but not only land use manager, but everyone who has access to human footprint inventory data set, to provide value neutral, high accurate data set to allow to making better decisions, whenever you are in a part of land use framework, or setting up triggers for some decision-making process, cumulative effect management, or you are dealing with species at risk, not only caribou, but also others. Our data are publicly available, and everyone within our stakeholders, but even outside of our organization, our stakeholders, is free to download data and start using data, analyze for their own purposes. So as I said, better information equals better decision. And in our world, in our geospatial world, how do we measure things? Well, we measure things by mapping. So we do create map data set, human footprint inventory, which is cumulative data set, collecting human footprint. Now, there is more definitions of human footprint, and ABMI goes or uses this broad definition where we are talking about native ecosystem transformed to support either temporary or permanent human land use, and it needs to be visible. So it needs to be identifiable on the surface. Now, if you look into our metadata, you would actually see that this definition of human footprint, this basic one, is a little bit breakdown. And within our human footprint inventory, we are collecting two different types of human footprint. First is alienating, and the second category is successional. So alienating human footprint includes all the types of human footprint that is designated or created by anthropogenic activity for long-term purpose. So that conversion from native land cover to anthropogenic is projected to be, if not definitely to be long time. And typical examples are cities, roads, industrial areas, but even agricultural land. Although there could be different opinions on some abandoned agriculture or cultivation land, when that abandonment essentially is going to produce back to the native species composition on the ground. So for some of the human footprint, there's a really like long-term persistent human footprint on the land core, but even for something that might be short-term, we always talk about alienating human footprint in that case. Now, successional human footprint, that's different category. And that's quite opposite. So human footprint that has been created for very temporary, short time modification. And let's say forest harvest areas or seismic lines are quite good example of that. And there is expected and right now even required by following the regulations that these type of human footprint are going to be converted back to close to natural state to the revegetation or replanting or the reclamation process to the back to the natural land cover. Now, within our human footprint data set, we do not discriminate in between those two cases, and within our data set, you are going to have side by side both cases of human footprint types or groups. Human footprint data set is a cumulative data set, which essentially means that we go by rule once human footprint, always human footprint. And we are adding additional information to the human footprint, let's say in the form of attribution. In this case, year of origin is being added to the polygon itself, to the spatial representation for user, including ABMI users, to make availability to model duration of the human footprint on the land core. We do map physical human footprint, which means whatever we see on the land core, we map, and that's essentially direct physical modification from that natural land cover. Now, how do we do it? If you look at this picture, everything what is not covered by polygon would be considered to be natural land core. So everything else we cover within human footprint polygon, and we do have different categories. So once polygon is being established, so essentially the spatial geography or spatial dimensions of these polygons are being captured, then attributions being assigned to individual features. And each polygon has not only geographic or geospatial representation, but also thematic attribution association with it. So you can calculate and report on different types of human footprint within your area of interest. Well, currently we maintain 112 feature types and 20 sublayers. So if you look at this picture, and Sydney, can you confirm whether you can actually see my cursor as I'm moving up and down?
Yes, we can.
All right. So by the color, you can see, let's focus on this light brown. Urban, industrial, miscellaneous, oil and gas, in here, clearing unknown and facility unknown. They are all represented by the same color, which essentially means that they are included in one sublayer, and that sublayer is in industrial features. But there are four different feature types. There are some sublayers where we have only one sublayer containing one feature type. So let's say this pipeline would be a good example of that. Now, on this visualization, I just want to demonstrate difference in between the cumulativeness of the data set. So essentially, once human footprint, always human footprint, and also ability to query and to model different scenarios. So on the left side, you see accumulation of the human footprint per period of time for harvest areas. And it's being just added from year to year. Well, this is a period of 8 years, refreshes every 8 years. But on the right side, you can see amount of polygons for the same time period, but only going 8 years back. So let's say for year 2019, you would see amount of polygons going back to year 2012, so 2012 to 2019. And I just want to demonstrate on this example that, for some type of analysis, you need to know all the human footprint that ever had happened on the land surface. But for some other analysis, so let's say if you are in forestry business and you would consider 8-year period for reforestation or regrowth of the natural vegetation, then obviously our query just 8 lives last year, and amount of polygons to use for analysis is completely different. So that's allowed within our human footprint data set. And I mentioned that we have 112 feature type categories, 20 sublayers, but also ABMI as one of the users of human footprint data set. Reports on amount of human footprint on the provincial scale, but also on some specific projects, so different areas of interest. And we are reporting as an organization into 6 categories: agriculture, forestry, energy, transportation, urban and industrial, and human-created water bodies. Report could be found, and see, I don't know if you can just probably to the chat, just place this link for everyone, so they can actually browse later, or even right now as I'm talking, through their online report. So everything what we map is being summarized within online report, breakdown through the categories, breakdown through the areas, including visual aspects of mapping, and it's available for everyone to see at our corporate or our organization website. ABMI started to collect human footprint back in 2007. And at that time, the first order of business was essentially to figure out what's existing in a space. And there are some data sets existed at that time in independent silos of the data, managed either by government or by private organization. And through the federal or provincial governmental organizations, we were able, as ABMI, we were able to collect roads, railways, industrial features, some base features, seismic lines, and start collecting it into one integrated data set. But there were a lot of features that were not captured. So let's say residential areas, cultivation. So ABMI at that time started to add those on our own program by digitization or by applying remote sensing classification and so some sort of automation plus quality control on top of that, so some semi-automated process, and started to build that seamless wall-to-wall data set covering entire province. Also with some private sector help, let's say the harvest areas, we've got access to some of those to forestry companies, plus again by digitization, quality control, and improved on whatever has been existing. So in 2007, ABMI released first data set called W2W, which means wall to wall, and that meant to be expressed that entire province, east, west, north, south is covered within that data set. And this data set was released later, updated and re-released 2010 and in 2012. In 2014, however, ABMI made a decision to improve standards of wall-to-wall data sets significantly. And those major improvements focused on three areas: geometry improvements, so spatial component, attribution, so that thematic component, and structure itself. So we went to individual sub-layer structure at that moment. And also one of the biggest decisions was that annually updates are possible. And since 2014, ABMI released annual updates of human footprint inventory. So we sort of rebranded from that wall-to-wall type to HFI type. Now, what's very important to mention in here, that in 2014 also HFMP was established, and HFMP stands for Alberta Human Footprint Monitoring Program, which proven to be essentially not only very important, but almost crucial to maintain high quality data and that value added or value neutral data set. where this program consisted from two sponsors, ABMI and AEP. It has three committees: data steering committees, stakeholder steering committees, and technical committees. Technical committee meets once per month. Currently, we have 14 members. Membership on technical committee is focused more on technical aspect. What is the progress of the program? What do we need to next, kind of immediate goals? And membership consists of ABMI, AEP, AER, Forest Research Institute in Jasper, and some academia as well, to provide that broad spectrum of opinion and connect with subject matter experts whenever it's needed. What is important in here, that in 2014, when this program was established, government of Alberta actually not only provided reference data sets, but actively participated in creation of the data sets. So some sublayers were created by this program, HFMP, and those were released to the public space as an open data sets. And then ABMI stepped in, took those data sets into the human footprint inventory program, where modifications were needed, some updates were applied, and those sublayers became integral part of HFI process. So very, very important program. HFMP aims to be value neutral, scientifically defensible, accurate, documented. So there is a lot of documentation existing to explain all the processes that are involved in creation of those sublayers. As I mentioned already probably a couple of times, we aim to provide a value neutral data set. Essentially, when we see human footprint, we capture it, but it's not biased by any opinion. We just capture it as we see it. We are trying to be as accurate as possible, as consistent as possible overall through the entire province, and scientifically defensible. So we think that we know what we are doing, and we value all the high-end science that is being published and documented in this field. Data structure itself, once data set is completed, we do release it in ESRI file database format, so that's GDB. And again, on the right side, you can see that this database it consists of 3 featured data sets. So on the top, we have integrated data sets of human footprint per particular year. So within this layout, we have HFI 2018, but for each year of HFI from 2014 to 2019, the structure is the same. So we have integrated data set, we have linear features, and we have sublayers. Those linear features and sublayers are similar, but difference is that feature classes within the data sets we have in form of lines for linear features and in form of polygons for sublayers. So let's say roads, we do have 2 representations, one in linear features, so there is a linear network, and once in the polygons when those center lines were buffered or widened to create actual polygons of it. And that's because ABMI mandates a report on area of human footprint. So we need to essentially even that line or convert back to the polygons. All these sublayers are maintained individually, and that is one of the biggest changes from wall-to-wall to HFI standard, when individual sublayers are maintained on the individual level. So what it means essentially, if you are interested, so let's say only in the pipelines or only in the harvest areas, you can extract that information directly from a GDB file, and you can run your analyze your modeling only for that particular sublayer. What is important in here that after all these 20 sublayers are cleaned, we run integration process to create one seamless data set containing all of the sublayers, and the process is based on order of precedence. And here's the list of the layers within the appropriate order of precedence, which means the lowest order of precedence is assigned to be seismic lines and the highest it's assigned to be reservoir lines. Now, because we have these individual layers maintained individually, right, separately, then if for whatever reason your organization would need to switch order of precedence, so reorder these layers, everyone can do that. Each user can do that and just replicate that process with different order of precedence. These are the layers displayed for HFI 2019. And as I said, attribution, spatial component, topology, everything is clean and finalized for individual sublayers. But if you are interested on overall amount of human footprint, we also integrate those 20 sublayers into one layer. So we don't have to have overlap in between different sublayers, because essentially that's what's happening on a surface. Some areas could be developed first, let's say as a for example, a gravel pit, and later on convert to I don't know, golf course. So that would be two different sublayers, and there is overlap in between those sublayers. But if you are focused only on one category and you are not really paying attention to anything else, then you can grab it and run it at the end as an individual separate sublayer. And this is how 2019, so that's the latest release of human footprint, looks like. Integration process itself is formed on cookie cutter principle, where spatial representation of a sublayer with higher order of precedence cuts into the sublayer underneath it. So let's say seismic lines are being cut by pipelines, and then harvest areas comes and cuts through all of those. So both seismic and pipelines up to the highest level, which right now is being held by reservoirs. But again, if order of precedence needs to be changed, individual sublayers could be organized, and this process could be rerun on user computers. How do we actually capture polygon? We use a process called heads-up digitization, or digitizing, where we need to zoom. First we have to interpret or identify that area has been changed. We do that on imagery. And this imagery that I'm displaying and using for this visualization is a little bit higher resolution. It's actually quite high resolution. Most of our interpretation is being done on spot imagery with resolution a little bit lower than this, what we are seeing. But bottom line is, once a human footprint has been identified, the human footprint needs to be captured to the polygon, and then it needs to be interpreted. So not only a boundary of this polygon need to be captured, but qualified personnel needs to make a decision how to call this human footprint, which one of those 112 categories this human footprint falls into. And we do have trained professionals in our team with standardized program of how to went through the training. So there's mandatory days in the office. We go to the field for field validation as well. We hope that after 2 years of this current condition, we will be able to do that in this summer. Hopefully that will be possible. But essentially, we do have a program how to train and how to make sure that our interpreters not only know how to interpret, but also consistent. They are consistent from each other, comparable to each other, so we know that our quality or entire province is equal. And I mentioned that we have in-house image catalog. It is in quotation mark, which essentially means that we do have access to information, mostly through data sharing agreements. Some of these catalog items we are helping to create as well. And it starts with 1950s ortho. Then we do have high resolution ortho photo for 1980s. That's not being available right now for entire province, but we are getting that. Obviously, there are some open source data as a Landsat from 1984, 2000. Downfall of those is lower resolution, so 30 meters, 15 meters. And then we have IRS satellite scenes, but most of the interpretation is being done actually on spot imagery, going from 2005 to 2019. It started with black and white 2.5 meter resolution, and since 2013 actually, there is a RGB component 1.5 meter resolution. We go outside of our in-house catalog for information as well whenever available, and very good source of reference data or reference information from imagery point of view, proven to be Earth Engine Google time-lapse, where entire globe cloud-free coverage is available for years going from 1984 up to 2020, I believe it is right now. So obviously we use it up to 2019. And just recently we found out that City of Calgary has created this image server, and within proximity of City of Calgary, you can actually find imagery back to 1924. So every time we see something existing and it's open source and we can link it to our database, we'll gladly to do so. On the left side of the image, you can just see of my slide, you can see two images going back and forth in between the latest 2019 and 1980 imagery. And obviously you can see that spatially it fits quite good, and it helps us to determine year of origin for particular human footprint. Now, if you look at this image catalog a little bit closer, you see that for 1950, and we always call it circa, like approximately 1950s, because let's say in this case, the actual mapping happening between 1949 to 1951, with some exception of some areas flown in 60s. So we just kind of average it and say, well, everything what we see on this map, it is circa 1950 time period or time epoch. And we do have entire 1950 orthophoto available for us. We have actually created it or helped to create it from archive maps. So paper maps relying in archives. We scan it with high resolution scanner and then georeferenced it. But entire process resulted in a spatial horizontal displacements, and those displacements could be up to 200 meters. And we actually have exact documentation what that displacements are, or accuracy in horizontal dimension. And therefore, we use this orthophoto just for the reference, essentially to give us an answer on the question: has human footprint existed back in 1950, yes or no? Now for 1980s, and on the left side, you can see current coverage. We actually auto-rectifying this data set by ourselves. ABMI and Government of Alberta created project to run aerial triangulation from mapping that has been completed in between 1980 to 1985, plus some areas has been again flown late in 1990s. And from those individual frames that are archived through the scanning process in provincial archives, we are creating orthophoto seamless mosaic for entire province, and not only high resolution, which is 1.25 meter, but high spatial accuracy allow us to digitize if needed directly from the source. Now, why we are doing it on a provincial scale, we are able to run full temporal analysis on layers that each polygon of those individual layers had been added, or information about year of origin is known and had been added to this data set. So we do not have it for entire human footprint. And in here, there is a list of all sublayers within our data set and percentage of completion. So there's 11 sublayers that we already have all year of origins assigned to all the polygons on the provincial scales. And we are getting there for the rest of the sublayers. Some sublayers take a lot of time to complete. There's millions of seismic lines. There's a lot of kilometers of pipelines and cultivation residential. There is a lot of polygons. Overall, after integration, our data set contains more than 5 million polygons. So you can imagine that to go through that amount of polygons, this process, it's quite time extensive. But there are some automation processes that we are including into our workflow. But at the end, we are aiming to get seamless coverage of on the provincial scale of human footprint with fully temporally data ready. While we are not there yet, we have created this temporal human footprint data set on what we call sample scale based data. So within province, we do have our sites, ABMI sites, distributed 20 kilometers by 20 kilometers and with spacing and dimensions 3 kilometers by 7 kilometers. And within all of these square rectangles, and you can see on the left side imagery, on the right side polygons. Each of those polygons within the rectangle were attributed with year of origin, which allow us, so here you see on the left side, the distribution is complete and with a regular spacing for entire province. And 3 kilometers by 7 kilometers. So let's say even if that seismic line outside of this rectangle, we do not know year of origin. Within rectangle itself, we do know that year of origin. So we spend extra time to go through all of these sample-based rectangles, and at the end, on entire provincial scale, temporal human footprint product has been created. And what it allows us to do, so anywhere in a province, you can create that temporal temporal representation. So essentially, how to see how that human footprint has been developing over the time period. And it starts in 1950s, and it jumps to 1980s, and then to 2000. So those are those 3 points in time periods, when we know the circa products, and we have those reference data to confirm whether human footprint has existed or not. So essentially, a trend line is kind of connection of those points in between 1950 to 1980, and then another 2 points from 1980s to 2000, and going on from 2000 up to 2019, with the exception of 2 years, there is a year increment values or areas known for each of these segments. And obviously, this is just a visualization how to model this trend analysis once you have the data collected. And this is just a short segment in time going from 1999 to 2013. But again, we can do that going back to 1950s and up to last year update, which is 2019. What is the accuracy of our data? And I mentioned on previous slide that we, as an organization, we collected all the existing data sets from sources that were available to us. So essentially, accuracy of the data is really source dependent. If, for example, we got spatial accuracy and the data come from GVI, and we know that for upland that accuracy is plus minus 5 meters, we have to essentially be upfront and say, well, this is accuracy we can achieve with our data set. It cannot be higher. The same for thematic accuracy, right? If GVI claims it's 65% accurate, we might improve on it, but essentially that's what it is in our data set. And on spatial accuracy, you can see that for the base features, which is one program of the government of Alberta, there is a wide range of accuracies going from 5 meters up to 100 meters. We sort of stayed away from these, but let's say 10, 25 meters. So essentially, again, it is source dependent. Whatever data were coming into our data set, we simply had not had chance to modify each polygon if we see that they are not fitting. We do a lot of updates, and if we see that there are some horizontal errors, we definitely correct those. But overall, we have to depend on the reported accuracies in existing metadata of the data sources. Now, for our heads-up digitization, we have to refer to the accuracies of the image itself. So let's say, even with very thorough digitization following each vertex by vertex with the scale of 5,000, which is standard for digitization. We cannot be higher with accuracy as the image itself. And when we know that image, which is spot satellite scene, has accuracy of 10 plus minus 10 or plus minus 20 meters, that's what our polygon is going to be. We were not completely happy with these general statements. So last year, we actually re-evaluated accuracy or thematical accuracy of our data set in these areas, and it was part of the project completed in last year. And again, Sid, if you would not mind to copy and paste this link into the chat for everyone to have a look if interested. So essentially, over areas of 20 townships situated in northwest portion of the province, Caribou Mountains and Chinchaga Caribou Ranges. We flew these areas with high resolution imagery, and that high resolution imagery was used to interpret human footprint, and compared to existing human footprint, in that case, it was year 2018 that we compared to. And we found out that overall accuracy, thematic accuracy, so attribution, was over 90%. It was 93.44. And there is a breakdown depending on categories. So we are interested to see what are those categories and what are where errors that we are finding. So you can see those breakdowns listed within this project. It was one of the outcomes of this project. So it was not the only one, but one of the outcomes. But we are happy to see that our accuracy is about 90%, so 93.44, and that's what we are aiming for. So to be over 90% in thematic accuracy. And I believe that was actually my last slide, so I don't know how we are doing on time, Sid. I think we are right there.
We're right on time.
Yeah, so thank you, everyone. As I said, I mean, I wish we can do that in person